together for you, I can explain that. Alright, so what we have is, hello Year 3, today's video lesson is all about how a material changes from a solid to a gas. Okay, so the state that a material is in is largely due to the arrangement of its atoms or molecules. So in a solid object, the atoms and the molecules are arranged in a fixed state, and they're held together by rigid bonds. They cannot move, they cannot change their shape. When they begin to warm up, those atoms and those molecules start to vibrate, and they vibrate and they vibrate and they vibrate until they reach a certain temperature where those bonds can't stay locked together any longer, and that's when those bonds loosen or break, and then they can move freely around each other. When that happens, they have melted, okay, and then they've gone into a liquid state. Once they're in a liquid state, if we continue to apply heat, they will roll around and roll around and roll around until they're all completely melted. Then they're going to start vibrating again. They're vibrating and vibrating and vibrating while that heat is being applied until they get to the point where they can't vibrate any faster, and that's when they start evaporating. Ping, 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 ping. And those little tiny molecules of water start jumping out of the liquid and then going up into the atmosphere, and that's when they become a gas. Okay, so we go from a solid to a gas. If we have a look at this graph that I have put together for you, I can explain that. Alright, so what we have is the amount of heat required to take H2O from ice to vapour. Now this was only a small amount of ice. If you had a larger block of ice, of course it would take a lot longer, but this was a small block of ice that I used. So we started with a block of ice that was below 20 degrees Celsius, so that's definitely below the freezing point of water. I put this onto a hot plate, and it did not take very long at all for that small block of ice to melt. What that means is when I applied heat, the molecules inside that ice cube started to vibrate, 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 vibrate until they couldn't vibrate any faster without their bonds breaking or loosening. Once they got to that point, they started to melt. Once they all melted, the ice or the solid had become a liquid. Once that happens, guess what? They start to vibrate again. Vibrate, vibrate, vibrate. While they're a liquid, they're vibrating and rolling around and moving faster and faster and faster and faster until they get to 100 degrees, which is the boiling point of water. And at that temperature, that's when the water is rapidly boiling and is evaporating into the air. Okay, you've probably witnessed boiling water before. Once it's boiling, it is evaporating. Once it's all evaporated, it becomes out into the atmosphere, into a gas, and that's when it expands and fills up the space around it. Okay? So a few things that we need to remember about that before I show you a quick demonstration is solids have molecules that are linked together with rigid bonds, so they keep their shape. I'll duck down. I'll sit on my stool. Okay? Liquids, their bonds are weaker, and that allows the molecules to roll and slide around each other. Okay? The amount of heat is directly proportional to the speed of the vibration of the molecules. The bonds between molecules of materials can only withstand a certain amount of vibration before they start to change states. And different materials have different boiling points and different melting or freezing points. They have different melting, freezing and boiling points. So some materials, like metal, require a lot more heat before those bonds, those rigid bonds, will break and loosen, and then it will start to melt. Okay? Chocolate, another one that I know of because I like to eat chocolate, I know that the melting point of chocolate is 35 degrees, which is a bit higher than the melting point of water. Okay? So that's some things that we need to remember. Now I'm going to show you a little demonstration. These marbles right now are in a solid state. because all of their structure is, they're locked in a structure. They are not changing from their shape or structure, so they are solid. And here's something that you probably don't know. Even when a material is in a solid state, those little tiny molecules are vibrating ever so slightly. They never stop moving. They're always vibrating just a little bit. Oops, but not enough to break their bonds. Now what happens when we apply heat to a solid is those molecules start to vibrate faster. All right, this is when it's going to start to get a little bit noisy soon. They vibrate faster until those bonds cannot withstand the vibrations any longer. Oh, I better watch where the video is pointing. So they vibrate, 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 vibrate until the bonds break. And then they can roll around. This is what they look like when they're in a liquid state. So see, they stay together. However, they can move around. So their bonds are very loose in a liquid state. If we continue to apply heat, what happens is we start to vibrate again. And we start to vibrate so much that they can't stay in a liquid state anymore. And they evaporate and turn into a gas state. That's it for today. Bye.